Hello, my name is Sarah Gaichas, and I work at the Northeast Fisheries Science Center for NOAA in the United States in Woods Hole, and I've been asked to give the keynote at the Atlantis Summit on Atlantis and stock assessments. So the talk today is challenging assessment models with realistic complexity. And before I even start, I'd really like to acknowledge all the many people who have contributed to this talk, including Christine Stawitz, Kelly Johnson, Alexander Keth, Alan Hicks, Sean Lucy, Emma Hodgson, and Gavin Fay for Atlantis OM development, Isaac Kaplan, Cecilia Hansen, and Beth Fulton, obviously, for Atlantis and Atlantis modeling, Bai Lee, Alfonso Rodriguez, and Howard Townsend for using the Atlantis OM outputs in assessment modeling, and Patrick Lynch for designing skill assessment overall for our project. So, first I'm going to give you a little roadmap of this talk. The main idea here is to talk about management decisions and models and assessment model testing. So what I'm talking about today is not using Atlantis as an MSE, not using Atlantis as a stock assessment model, but using Atlantis to test stock assessment models, specifically performance testing. So for that, we need to understand what the models need to do and the challenges with what they need to do, and how I think, at least, Atlantis is uniquely positioned to address some of these challenges. And I'll give some examples of what I mean by skill assessment, first of all, and then how we're trying to do this with Atlantis outputs. And for that, I'll give a quick overview of the R package Atlantis OM, which was developed starting at the first Atlantis Summit in 2015. Then we'll show some examples of the outputs of that package, and also some examples of using that information to work with single species models, multi-species models, and some ideas for looking at assessing the skill of other models, including ensembles. And then what I'd really love to discuss at the summit is what to do next. So I think we have some good building blocks here. We're much further advanced than we were at the 2015 summit with respect to both the Atlantis model itself, the outputs, the documentation, and the Atlantis OM package that samples from this and creates data for input into different models. But it'd be really good to discuss how to automate some of the rest of the process that we're actually having some difficulties with that turns out to be quite challenging, which of course we should have known. Also verifying what Atlantis output we should or shouldn't be using in this process, whether there are any new outputs from Atlantis that would be useful here, and what would really be best practices for creating data sets from Atlantis to do model skill assessment, and also for parameter estimation for those models. So it's not just time series, but you need to specify the different parameters going into the assessment models. And our friend Poseidon will be following us through this talk here. The original talk was named the Poseidon Adventure, and so you'll see why, hopefully. So the bottom line is we do a lot of assessments. There's a lot of management regimes throughout the world that take things like observations and data, do research and modeling, and then do synthesis and assessment specifically to give management advice. And so this is just a slide, it's actually rather old, that's based only on NOAA fisheries in the US, but it shows just the number of resource management decisions that need to get made that are based on this science enterprise. So it's over 400 species that need assessments. It's 117 marine mammals, and an additional 93 ESA, that's Endangered Species Act listed species. There's over 2,000 habitat actions, over 200 aquaculture actions, and lots of NEPA, that's the National Environmental Policy Act actions. So that looks at cumulative effects, and there are 11 large marine ecosystems. This is just the United States. Obviously, there is a lot throughout the world that is very similar. And so the sheer number of assessments that need to be done is gigantic. So we do these assessments largely relying on mathematical models in a lot of places. And so there's a lot of different kinds of models that we use. Many of the models are single stock or single species models, but there are also multi-species models. And increasingly, we're seeing more aggregate biomass, food web, and ecosystem models, not all brought to bear on management decisions, but certainly in the management sphere, asking questions, doing scenarios, etc. There's economic assessments, there's social impact assessments, there's just a wide range of models. So the question for this talk is, how do we know they're right? For stock assessment models, typically we'll look at fits to historical data, so hindcasts. We'll look at the influence of that data over time, so we'll do retrospective diagnostics. The aim is usually to keep models as simple and focused as possible, and this is in order to keep them, in our minds at least, more accurate. And there is quite a bit of simulation testing of models, usually at the very least self-testing of the model, so can it recover parameters that it generated itself. So that's all great, but I'm going to argue that it doesn't go quite far enough, because what if we have really noisy data? What if we need to model complex interactions? What if we can't just model the simplest and most focused thing? And especially, what if conditions are changing over time? Now, this is something that I think everyone recognizes. There's a lot of things we already need to know about fisheries. It's already a fairly complex system. So how many fish can be caught sustainably? This is the basis of most stock assessments. So for that, we need to know how many there are right now, how many were there historically, how productive are they in terms of individual growth as well as population level reproduction, how many are caught right now, and how many were caught historically. So these seem like fairly straightforward questions until you realize that the fish are underwater and not able to be observed all the time. And so what we do instead is have to estimate these things using models. And so the models need to estimate things like current biomass overall, and usually at age or size, to understand the population dynamics better using a population dynamics model. They need to reconstruct the past population dynamics. They need to be able to model some of them, both individual and population growth. And ultimately, they need to be able to output how many should be caught next year. And also, importantly, how certain are we about that? Because in a lot of management systems, the uncertainty in our outputs has a large effect on what the overall catch advice will be. So add to that now I'm putting new in quotes here. These aren't really new questions and challenges, but as we move towards ecosystem-based fishery management, these questions are much more in the forefront, and the management objectives turn out to be a bit broader. So we don't need to just know that list of questions on the top, but we need to know what supports the fish stock productivity. What does their productivity support? So is there something other than fishing that fish is out there supporting in terms of ecosystem services? Maybe it's a forage fish. Maybe it supports other fish. Maybe it supports marine mammals. Maybe it supports other industries. So how do those fish interact with other fish, with fisheries, with marine mammals? These are all important things. As you can see, it's getting more complicated. And then we have, how does the environment affect them and the environmental change that we're seeing? And there are also really important questions around ecological, economic, and social value to people in terms of the fish population. So the already not very simple questions are getting more complex all the time, and the models need to be able to address maybe more things than they used to in the past. Also, the management objectives are broadening, and what we're calling, at least in our ecosystem reporting in the Northeast US, the risks to meeting fishery management objectives are also getting a bit broader. And so a little over a week ago, we've been presenting our ecosystem reports to our fishery management councils, and this is a large section of the report. It deals with climate change. It deals with other ocean uses, such as wind energy development. It deals with all of the things that they don't usually deal with in their day-to-day species management. So what are the currents doing? How's the phytoplankton? What's going on with the forage species? Are there apex predators we need to think about? And what are the other ocean uses that might impact being able to meet our management objectives for our stocks? One of the pages in this report just talked about climate change indicators. There's a lot of others, but I think, like in many jurisdictions, what we're seeing is there's a great deal of warming. There's been a lot of change. We're seeing changes to ocean currents. I don't know if you'll be able to see my cursor, but this is the Gulfstream Index, which measures how far north one of the major ocean currents is in our region, and it's going further and further north all the time. It's actually in sort of unprecedented territory right now. We're seeing warming bottom temperatures over time. This is just in the mid-Atlantic, but it's throughout the whole region of the Northeast US. We're seeing basically a phase shift in the number of marine heat waves in the last decade or so. And of course, over here, you just have your sea surface temperature anomaly maps just for the last year, 2021. You can see fall was basically just about as warm as it could be. In all seasons, we're seeing increasing sea surface temperature. In the fall of 2021, we were basically in a constant heat wave in the mid-Atlantic region. So this sort of thing impacts the assessments. I think assuming something like stationarity and what's going on in the conditions for the species really doesn't make sense under these conditions that we're observing across many ecosystems around the world. The stock assessment community is well aware of this. There's no denial that this is happening, and there's a real obvious need that's been stated by many people in the stock assessment community that we really need to understand changing climate and ocean conditions. They do lead to shifting species distributions, changing productivity. They affect the fishermen directly. And so this paper by Melissa Karp et al. In 2019 really tried to outline what climate-ready management might look like in terms of stock assessment. The needs they identified in that paper were that we do need to improve our ability to project global change impacts in the ecosystems around the world. Now, here's a part that Atlantis can play already, and something that's going to be talked about in the summit before we even get to this topic, and it's obviously something that Atlantis can do very well. The other thing that they pointed out as a need was that we need to test the performance of stock assessments to these impacts, right? So these are the tools that we're using to provide management advice, and we need to understand how all these changes are affecting their ability to estimate the right quantities. Really, to me, the bottom line is we should be able to design assessment methods that can perform well despite these impacts. That would be the overall goal. We're still going to need to do stock assessment. We just want to make sure that our tools are working well under changing conditions. So this is where skill assessment comes in. As I mentioned before, a lot of what we do in fisheries stock assessment is we'll look at fits to data, we'll look at retrospective performance, and all of this is very important, and I'm not trying to downplay that at all. It's critically important to look at these things. Unfortunately, when you have a lot of observation error, it's very difficult to tell if fitting to your observations is getting you any closer to the truth. And so there's some really nice papers that's been written on skill assessment, which is trying to evaluate how far your model prediction is from the truth, not from the data. There's been a lot of really nice papers on that lately, especially for ecological models. And I suggest looking up this Journal of Marine Systems special issue. I will give everyone a copy of these slides, and these are all live links here that are read. One of the papers in there was by Stowe et al. In 2009, and it greatly inspired the paper by Olson et al. That looked at skill assessment for Atlantis models in 2016. But the main idea here with skill assessment is you have your truth, it's this little green dot here, and you have your observation, which has some error, it's some distance from the truth. And a model without much skill will make a prediction that's far away from the truth and probably also far away from the observation. So this is what you don't want. You don't want your prediction to be way far away from both the truth and the observations. Ideally, you want your model prediction, your truth, and your observations to all be within the observation error. That would be great, except in a system where we have a lot of observation error, it is very difficult to tell where this little truth guy is, right? And so one thing that I think we should do more is simulate data, because we will know what the truth is from the simulated data. Now, the difficulty is, how do you make data that's as challenging as it is in the real world? And here is where I think Atlantis can come in, obviously. But back to skill assessment, there's multiple metrics for skill assessment. So you can look here, in the Olson paper, there was a nice figure that looked at what our observations might look like relative to our model output. So the observations are all the little dots and the model output are the lines. And if you had a perfect fit, you would run through all of them. You could have perfect variation, but the wrong scale, and that would look like this. These are all the ways models can go wrong. And there are varying degrees of how bad these might be in terms of giving management advice. There's perfect inverse variation. So you still have the right trend, but it's just going in the opposite direction. You have completely uncorrelated model, but it's on the correct scale. You have uncorrelated and it's not even on the right scale. And then you have uncorrelated with a trend to mismatch. So this might be your worst case scenario over here. There's a lot of different ways to measure skill. So we could look at correlation. correlation will work really well with a perfect fit. But when you have the scale off, it won't give you as much information, say, or when you have perfect inverse variation. So correlation is one good thing to look at. It might tell you there's just a cloud of points around your line and it's uncorrelated completely, or you start to lose information here. If you look at that along with things like the root mean square error or these other information criteria here, you can start to get also an idea of scale as well as correlation. And the MEF, the model efficiency criterion, is another one you can look at that measures basically how well your model is doing relative to if you just took an average of all the data. And so there's multiple ways to measure skill of a model relative to the truth or the data. And we want it to be relative to the truth. And so what many of the recommendations are is that you would use multiple of these criteria to try to get at basically all the ways that your model could be doing things right, but doing other things wrong. And it's really valuable to know this when you're starting to give management advice, because your models are going to have strengths and weaknesses, and you're going to want to know which is which so that you can play to them in terms of which tools you might use to answer certain questions. So here's a really nice example of skill assessment with ecological interactions. So this is Vanessa Trujillet's paper from 2020. And what she had was a multi-species state space model that she used to simulate basically single species assessments from that data that she generated from her multi-species system, and looked at different assessment methods to ask basically how well they did or how far off they went. And her bottom line was that ignoring the trophic interactions that occur in marine ecosystems induces bias in stock assessment outputs and results in low model predictive ability with subsequently biased reference points. That's a direct quote from the paper. It's a great paper. I really advise folks to read it. And the outputs here are just showing you, this is one of the skill metrics here, just the relative difference. It's showing you the bias in the models as you go from fitting to basically a multi-species state space estimation model to the multi-species state space simulated data. You do very well for both of your species, cod and herring. If you do multi-species but not state space, basically you start to be a little bit biased, but look at the scale here. It's not that bad. Now, if you go to single species state space with a constant m, which is state space is supposed to sort of absorb a lot of your uncertainty, you start to see how biased you get, especially for the prey species over here. This is herring. And you start to greatly overestimate them. And the scale here is a lot different from the scale above. And then things go really crazy when you get to the single species state space, but you allow age varying M, which is one of the methods we try to do to deal with assumed changes in predation mortality. The bias is starting to get very high. The really interesting thing is these single species models actually fit better to the data by the criteria that we would use for evaluating a stock assessment. So we might have said these were better models using the criteria we use now. However, they were biased models and they were going to give the wrong answer. And so fit is very important, but it isn't everything. And this study really shows that very nicely. So this was just looking at those ecological interactions. Again, even this multi-species state space model doesn't include things like the climate change indicators I was just showing you. So the question is, what can we use to generate data that's almost as complicated as the real world to test our assessment models? Well, you guessed it, here we are at the Atlantis Summit. And so obviously, I think Atlantis is perfectly suited to this sort of thing. You want to have this level of complexity that you have in Atlantis, where you have a spatial model, but not so spatial that you can't run it, where you have everything all the way from environmental forcing to primary production, all the way through to fisheries, included in the same model framework, where you have the dynamics being emergent properties of the model rather than something you've imposed with parameters that are very similar to the parameters we use in a single species or even multi-species stock assessment. So the model structure is fundamentally different, and it allows the type of complexity that I think we have in the real world. And so this is a really good way to generate data to test models. And so we could do this, and again, I'm not talking about the MSE loop inside Atlantis, which is also useful, but for different things. I'm talking about really generating a lot of different data sets that we could run in currently operational models, either used for stock assessment right now, or in multi-species models or other models being developed, and you don't have to incorporate them inside Atlantis. You can basically run them offline. So Here's an example of that. This was work that Isaac and Cecily and some of us did a couple of years ago and are still working on, back when I was fortunate to be in Bergen for a couple of months. And so this just gives an example of an Atlantis model run where you would have basically the oceanography and the fishing that you can manipulate at the same time. And we're looking at two different models, the California Current model and the Norwegian Barents Sea or NOBA model, that we'll be looking at a lot of output from later from both of these models. And you can simulate a climate change even in the relatively simple sense of the California Current model. You just have present day and then a climate change, whereas the NOBA model at that time was implementing a more complicated ramped climate. One way or the other, you can simulate climate change at the same time as you simulate changes in fishing, and you can collect data from this period of climate change and changing fishing. And you can use that as input to a stock assessment model. There are a few other things here about maybe looping back in a projection period, running a B0 run with no fishing on any species. There's just a lot you can do with a smaller set of Atlantis model runs to create a large amount of data that could be input into stock assessment models. And so that was the idea here. Now these incredibly, difficult to read and small print schematics here are trying to give an overview of how you might do skill assessment with Atlantis. The one over here on the left-hand side was actually designed for the Atlantis Summit in 2015. This little thing that says Atlantis Summit right here meant the 2015 one, but here we are at the next one, and that's okay. We can keep doing this. I think we're much further along, actually. So the idea is this was Team Poseidon, the god of the sea, would come up with the actual true world and also specify how difficult the data sampling process would be and what sort of data quality would be input to Team Odysseus, which would run all of these different models here at different levels. You could do everything from single species up through multi-species. You could do biomass dynamics up to fully age structured, and have a design of different types of models that was intended to happen at a workshop, but is happening sort of bit by bit, and you'll see some of those examples here. And then a final workshop, which has yet to happen, would be where we would go back and compare the skill of all of these different models, both in terms of fit criteria, but as well as compare it to the actual outcomes in Atlantis. So that's the advantage that we have here. And a sort of similar approach that was much more specified for a particular set of models was developed when we were in Bergen a couple of years ago with this is the OMCC, that's the California Current Atlantis. This is the NOBA Atlantis. And we would select a species, a pelagic and a demersal from each. And we would basically run these scenarios I showed you on the last slide and develop different estimation models that were attempting to look at different ways of modeling growth under climate change. There's a lot of different hypotheses for how best to do this, and so you could implement a bunch of different models, and then you can ask how the stock assessments performed, and then possibly even go into this projection loop where you would take the estimated optimal fishing rates from the stock assessments and run them through Atlantis one more time and see how it actually did in the real world. So we haven't gotten to here yet, and we're even struggling to fit some of these models, but I'll show you that in a moment. We're just going to lay out all the dirty laundry here because this is the Atlantis Summit. And so I'm hoping that we get some thoughts on how to automate this process a bit more, because running Atlantis is complicated, but running stock assessment models is quite complicated as well, which I'm sure everybody knew. So how are we doing this? This is the Atlantis OM package that was started at the 2015 Atlantis Summit. And again, this is a link to this draft landing page for the package, and it just explains a little bit of the background, also how to get Atlantis OM. Anyone can get it right now. It's on GitHub, and what data you would actually need to run it. So I'm not going to go through this in detail because on the next slide, you'll see what the specifications are that you need to make. So this is the get truth part of Atlantis OM, and I'll let you go through. It shows what you need to specify in your configuration file. So that's what the first thing the user does, and then the user runs something called OM init with that configuration file, which runs a whole bunch of Atlantis OM functions, many of which were developed at the 2015 summit and some of which were developed since, but a lot of this progress was made at that summit. Then the user would select which species or set of species they want to look at for their assessment, and run the OM species. And so then it cuts down the really big file that is the true Atlantis run for everything into just the subset of species. And that can then be input into the next set of functions, which actually creates the data. So at this point, you just have the true data, but you need that for skill assessment to go back and compare it later. The next part of the workflow is to get the data. And so here it's obviously a little bit more complicated, and I'm sure you can't read this, but it is at that link back there. So here is where the user specifies the surveys. You can have more than one survey. You can have as many as you want. You can have 20 if you want to. Good luck organizing that, but you absolutely can. There's one file for each. In the survey, you specify the areas and times that you're surveying, the Q by species, the survey efficiency, the selectivity by species, how much biological sampling you want done, what is the CV of the index overall that you would like to specify. So you really are Poseidon here. You can decide all of this. What is the CV for estimating length at age? Because Atlantis estimates numbers and weights, but not lengths. So we estimate that in Atlantis OM. There's our new functions for survey diet sampling that require the detailed diet check file, preferably zipped. And for that, you specify diet sampling parameters, and then you specify your fishery with area time subsetting, biological sample size, and catch CV there. Then the user runs 3 more wrapper functions, that one that gets the index, one that generates the compositions, and one that generates the diet. And there are also environmental data functions to pull out of the physics NC file from Atlantis. So here's what some of the outputs look like. With perfect information for 10 of the species in the Norwegian Barents Sea model, you see in red what the survey sample was, the survey biomass, and in the lighter blue, it's the true B from the text biomass output. And you can see that because we've sampled in one season, we're skimming the edge of the full range of biomass for a lot of these species, but we're right on the mark. Then you can also specify a survey that has efficiency that's lower than 1 for many of these species, and also has some size selectivity. And you see now that the true data in blue here is quite a bit further from your survey, which is what you would expect in real life. You can do the same thing with age and length compositions. And so I apologize that the colors are a bit reversed in this one. So here, these are length samples generated by Atlantis OM. We've got capelin and we've got halibut. It's just a contrast in size between a couple of the species. So the red is the true sample and the blue is sampling in the survey after you've applied selectivity. And as you can see, you're missing some of the smaller fish in the survey. Similarly, in the ages, like I said, here the blue is the sample, here the red is the sample. So I'm sorry for that. But you can see a similar thing happens. The true age samples are lots and lots of little ones and less big ones. But as you're sampling with the survey, you're missing some of the little ones. And then you start to get the more fully selected. So as you would expect. Diet outputs are a lot of fun. You can look at the diet. This is cod in NOBA for each age group over the whole model run. And what you're seeing here is that they have an ontogenetic shift in diet. This is global diet averaged across the entire model run. This is diet for one season, but perfect information. And this is survey sample diet for fall and spring. And we've added some uncertainty and some noise in there. And we've added some unidentified species to make it look a little bit more like real diet data. So what have we actually done with this? So Isaac and others published a really nice paper last year where one of the examples was using the California Current Atlantis output to fit a sardine assessment. And so what you can see here is sort of the stages of that. So the real biomass for California Current sardine in that model is here in the purple line, and our survey estimated this level of biomass. So I think it was a 50% efficiency, but it's still quite a good survey. Then we fit a stock synthesis model to this. And so the stock synthesis model is the green line here, and the survey biomass from Atlantis is here with the uncertainty estimates around it. And you can see the fit is okay, but it's not wonderful. Now that's where we would stop in stock assessment. But then with this, obviously, we can now compare the fit to the truth, and we can see how we are doing there. So interestingly, we're on a decent scale, but the trends are somewhat being gotten. But here is where, at the point where you can start diagnosing your assessment model and say, well, what's going on with this? There's some question whether we had issues with different growth than was assumed in the setup for the stock synthesis model. So this is still under construction, and we're still working on it. Similarly, Bailey and also Alfonso were able to work a little bit on a COD assessment based on the NOBA Atlantis model. And Bai made a lot of progress converting from the original SAM assessment to a stock synthesis assessment for NOBA COD. But then fitting to the output data from Atlantis is a little more problematic, and this is something we're still working through there. And I suspect this is similar to some issues we're having with some of the other models, which is it's pretty easy to generate time series for fitting to models. What's harder is to align the other model parameters with what would be expected based on Atlantis. So I think that's part of our work that we still need to do here. Another interesting example, and something we're working on pretty hard at the Northeast Fisheries Science Center as well, is being able to use this data to build and test multi-species assessment models. So what you see here is an example of a surplus production model, a multi-species surplus production model that's being developed stepwise. So they're starting with self-fitting, and now this is the stage of fitting to Atlantis output. And finally, skill assessment is going to be done using the Atlantis output. So you see some of the fits to their species here. They're actually pretty good. They can also do profiles for estimated parameters and test their model diagnostic tools with Atlantis OM. And a lot of this data is living in this MS Keyrun package, which people are welcome to look at. My question, though, is what should we be comparing some of these model parameters to? What's K from Atlantis? I would love to discuss that at this summit. So thinking ahead, another thing we can test is model ensembles, because we have a common data set that can be put into multiple models, right? And so we could look at a whole bunch of different universes based on Atlantis, but we can also ask, when we parameterize different stock assessment or multi-species models, what answers do we get, and compare the whole ensemble to the Atlantis output. So this is very similar to what we did a couple of years ago using a simpler length-based multi-species model, simpler than Atlantis, but more complicated than the multi-species production models, to test a set of production models. And we found this very intriguing result, which is that some of the production models did not do so well when it came to when you added survey bias and observation error to the data. They did pretty well when you had perfect information, but they were very simple models and they didn't estimate a lot of parameters. And so the interesting thing was the ensemble outperformed all of them under this fairly realistic data scenario. So this does suggest that exploring model ensembles is a really important thing to do, and I think Atlantis would be a great tool for that as well. So far we have run into some difficulties. I've already mentioned that. Understanding, for me, the Atlantis outputs, which is now much improved since the documentation was done within the last few years, or just after the last Atlantis Summit. So that's been a lot better, but I do think Atlantis OM is using outputs that are not often used in other applications. And so, and I don't run Atlantis to use Atlantis OM. I'm using the outputs strictly, so I can't stick a print statement in the code and see what happens, which is a good way to figure out what's going on. But again, I'm only working with the outputs. So I need a better understanding of the outputs. And I think, again, maybe some more tire kicking of some of these outputs that I'm using for Atlantis OM that other people are not looking at all the time could be really helpful and could be pretty efficient with some targeted group work. The other thing is reconciling some different Atlantis outputs. So which ones should I be using? Should we expect numbers in one output to match those in others if we're summing them up? For instance, some of the catch numbers aren't adding up between sort of the standard and the annual age outputs in some of my applications. I've been having some issues with young of year outputs. I think these are things that people have identified in other places, so it'd be great to discuss them a little bit more. And then there's some calculations that I'm wondering if they're correct. I've attempted to calculate M multiple times from just how many species, basically a catch curve, and I don't get sensible results a lot of the times. I do for some species, but not others. Per capita consumption is another thing I've tried estimating, but it looks like it isn't quite on the right scale. And so these are things I would love to be able to discuss. That's Atlantis related. There's skill assessment related stuff that also needs to be ironed out. So as I've noted, running stock assessment models is very difficult to automate. A lot of the decisions are made by one person who's iteratively running the model and doing diagnostic checks and making decisions. And so that is something that we need to think through if we want to make this efficient, especially if we start having like 100 different outputs from one Atlantis model we want to fit to. Also, generating the input parameters for the models that are consistent with Atlantis, like I said, can be pretty time consuming. Atlantis is just a little too realistic. So when I fit von Bertalanffy length at age models to Atlantis OM output for input into my length-based multi-species model, I don't get all of them converging, which is pretty interesting, but actually quite lifelike. And then also, what is M, like I said before. So there's a lot of things that I think we could still be working on here, and I really look forward to discussions on this. And so I'm going to close with this slide. Thank you so much for listening, and I really look forward to the discussion of this. So we're going to keep developing fishery stock assessment and ecosystem models. Can we build our assessments to keep pace with climate and other ecosystem changes? And I would love to hear your thoughts on this. So first of all, does anyone agree with me this is a good use of Atlantis model outputs? Because I might be in totally left field here. I think it's pretty cool, but it's obviously not what the model was originally intended to do. And so that's always, treading on thin ice when you start doing stuff like that. So I welcome any thoughts on that. I would love to hear about obvious errors in the Atlantis OM setup, things that I've completely missed the mark on, things that have changed since we started building it that need to be corrected, etc. And so also discussion on how to improve Atlantis OM if other people want to use it. We do have functions to write the specific model inputs in progress. So there's some for stock synthesis included in the package right now. I'm writing them separately for multi-species models because they're just way too complicated. Would we want a new package with skill assessment functions? We do need to update the documentation and improve the vignettes for this, and I would love to also integrate it and update it with other R Atlantis tools that are in concurrent development. It would be great to compare notes on that and sort of try to unify what we can. And then finally, I would love to have a discussion about what are the best practices to use Atlantis model outputs in skill assessment for stock assessment models, multi-species models, food web models, etc. So is there a spatial and temporal scale below which we should say, no, we're not going to do that, or above which it's not worth doing? Is there a way to calculate these assessment model input parameters from Atlantis outputs in a standardized way that would streamline things and also make things easier? Thoughts about storing Atlantis outputs for others to use. They're very big files. Other people are dealing with this, I'm sure, and any other discussion that we'd like to have. So I greatly appreciate your thoughts. And thanks again, and I look forward to talking with everyone at the summit. Thanks so much.